right, guys, today this is our last section that we're going to be doing for Chapter 8 for this school year. We will take a test next week over the sections that we have covered, sections 1 through 6. All right, so this section is 8.6 called Polygons in the Coordinate Plane. Now, we know what coordinate plane is. That's what you just did in the last section. And you should know what a polygon is. All right, we've talked about polygons in math before. They're a simple closed figure made up of line segments, basically. All right, and poly means many, so it has many angles, with really it being at least three angles. All right? All right, something important for you to remember. We always have this section, and this is a good time to take notes. Like I said, a polygon is a closed figure that consists of 3 or more line segments and 3 or more angles. All right? And when they mean by a closed figure, that means it has no openings. All right? So triangles are closed figures. Squares and rectangles are closed figures. Okay? It cannot be a circle because a circle is not made of line segments. All right, the distance, we're going to be talking about distance today, and just remember that distance will always be measured in positive units. You can't move a negative 2 miles, all right? You can't. You either went 2 miles or you didn't go 2 miles. So distance will always be in positive units. The ordered pairs are going to be the vertices of your polygon. Remember what a vertex is? Those connecting points, okay? Those are the vertices for a triangle. For a square, or a rectangle, those are the vertices, the corners, the meeting points of the line segments, okay? So that's what our ordered pairs are going to represent on our coordinate plane. And when you connect vertices, you should do them in order. So if the letters are A, B, C, you should connect A to B, B to C, C to D. If they're J, L, M, or something, just do them as much in alphabetical order as possible. All right, math has always got, everything has an order or a way to do it. All right, so make sure you're thinking that through. All right, now to draw a polygon in a coordinate plane, all you're going to do is you're going to plot your points first. Okay, so they said point A is 0, 0. So I go to my point of origin, which is 0. And if I move 0, that's where my point goes. And I'm going to label it A. And a lot of times you'll see them go ahead and they'll put 0, 0. Okay? Then for point B, I'm going to go positive 5. So I go across 5 and I go up to positive 7, which is going to be at the top of my number line. Okay, so there is point B, 5, 7. And then point C is going to be 4, negative 3. So I go across to 4, and since it's a negative, I'm going to go below 0 and make my point. 4, negative 3. Okay, now I'm going to draw my polygon, and I'm going to connect the lines. Oh, I forgot to label this as C. And the coordinates are 4, negative 3. Sorry. All right, so now I'm going to connect my points. So I'm going to connect A to B, B to C, and then I need to finish it off and go C to A. Because remember, a polygon is a closed figure. All right, so, and if I had a ruler, making the lines really perfectly straight would be even a better idea. All right, so you've just drawn a polygon. It's a closed figure made up of line segments. My vertices are where my ordered pairs were. That was easy, right? All right, now look at this. The key idea always gives us really good information that's important to remember. It says, when finding distances between points in the same quadrant, be sure to subtract the lesser absolute value from the greater absolute value. All right, so that's something we're going to remember. And you'll understand what they're talking about. We're going to be finding distance between points in a coordinate plane. And remember, we said distance will always have a positive answer. Okay, it will never have a negative number. All right, it says you can find distances between points in a coordinate plane with the same x coordinates or the same y coordinates using the absolute values of the coordinates that are different. Okay, so let's look at this. All right, points, and if you're finding them in the same quadrant, okay, here we have point -6, 2, and we have -3, 2. So the 2's are the same. So I'm going to take the coordinates that are different. I'm going to find their absolute value. The absolute value of -6 is 6. The absolute value of -3 is 3. And if they're in the same quadrant, which they're both in quadrant 2, all you do is subtract. What is 6 minus 3? It is 3. So it would be 3 units, whatever the units are. If they tell you, then you include that. If it says miles or meters or feet, they didn't tell us a specific unit, so I'm just going to write the word units. 3 units is the distance, okay? Now, if the points are in different quadrants, I'm going to add, okay? So I want you to think about that. Here we have the points 2, 1, and we have the points 2, -4. So I take the numbers that are different, okay, and I'm going to add them. All right, so the absolute value of 1 is 1. The absolute value of -4 is 4. So what is 1 plus 4? It is 5. So this would be 5 units. Okay, let's practice. All right, let's go ahead and look at a couple more examples that they've given us. All right, they've said find the distance between -3, -5, and 2, -5. And you don't have to have the picture, but you can. Sometimes the picture and using the coordinate plane is very helpful. It gives you a way to look at it. All right? The other thing you can do is you can take your 2 coordinates, -3, -5, and 2, -5. Okay, which ones are different? Well, these 2 are the different ones. Okay, and I can tell right now that they're in 2 different quadrants because one is negative and one is positive. They won't be in the same quadrant. So when they're in different quadrants, I take the absolute value of each number and I add them together. So the absolute value of -3 is 3. The absolute value of 2 is 2. So 3 plus 2 equals 5 units. And if it helps for you to have a picture so you can tell which quadrant they're in until you get used to it, that's fine. But anytime you see a negative and a positive, no, they're not in the same quadrant. They can't be. All right, now it says let's find the distance to this one. We have 3 and a -2.5, and we have 3 and a -5. Okay, now the numbers that are different are both negative. And if you look, they're in the same quadrant because they are both negative. Well, when you have them both negative, they're in the same quadrant, all I do is I subtract to find the difference, the absolute values. So what's the absolute value of -5? It's 5. What's the absolute value of -2.5? It is 2.5. So now I'm going to take 5 minus 2.5. And if you need to set it up like this, you can. Just remember, this is the whole number 5, so it has a decimal with a 0 after it. Don't just stack 5 over here above the 5. That wouldn't be right. Okay, but when I take 2.5 away, if you want to do your borrowing and all of that, you're going to find out that you're going to get 2.5. So my distance would be 2.5 units. All right, let's find the distance between these points. And again, you can do it using your diagram. We'll do it both ways. All right, so on number 3, they gave me -6 and then 6.5. So I start at my point of origin, I go over to -6, and I'm going to go up to 6.5, which is going to be right here in the middle. My dot's a little bit high, but right there in the middle of 6.5, it's not quite to 7. Okay? Then I'm going to go to my next coordinate, which is -2, 6.5. So I go back to my point of origin to 0, -2, got it, and I'm going to go up to 6.5. So I'm right back here. All right, now what do I know about my points? They're in the same quadrant. When they're in the same quadrant, I'm going to subtract. Or for those of you that just like using the coordinates, here's what you do. You write your coordinates and you only deal with the ones that are different. These both have 6.5, so I'm going to be using these two numbers. I'm going to find their absolute value. Absolute value of -6 is 6. The absolute value of -2 is 2. 6 minus 2 is 4. So they moved 4 units. All right, so let's go ahead. I'll erase this and we'll do the next one. All right, let's go ahead and look at this next one. All right, -4, 2. So start at your point of origin, go over to -4, go up to 2. -4, -5. I'm going to go over to -4. I'm going to go down to -5. I just wanted to erase. All right. Now, I tried to get rid of that mark and it won't go away, so I'm not sure why. But anyhow, let's go ahead and look at our coordinates. We have -4, 2. We have -4, -5. Okay, my x values are the same, so I'm going to deal with my y values. All right, are they in the same quadrant? No, they're not. One is negative, one is positive. So I will add the absolute values. The absolute value of 2 is 2. The absolute value of -5 is 5. 2 plus 5 is 7. 7 units is my distance. All right, modeling real life. You think, oh, I don't understand when any of this will ever be useful. Well, let's look at a situation. An archaeologist divides an area using a coordinate plane in which the coordinates are measured in meters. The vertices of a secret chamber are, and it gives the 4 coordinates, find the perimeter and the area of the secret chamber. Now we're going to take everything we've been learning in this section and we're going to use it to find area and perimeter. Okay? First, let's understand the problem. We are given the vertices of a secret chamber, and you are asked to find the perimeter and the area of the chamber. So I know I need to find perimeter and area. So I'm going to need to make a plan. The first thing I need to do is I need to plot and connect the vertices to draw my polygon that represents the secret chamber. They did that for us right here. They took the coordinates -8, 10, 4, 10, 4, 2, and -8, 2, and they've drawn their secret chamber, okay? So using those coordinates, so they did that. it says then now I need to identify the polygon. Okay, it's a rectangle, isn't it? That will tell me what formula to use to find perimeter. When we're finding perimeter of a polygon, of a rectangle, my formula is P equals 2 times the length plus 2 times the width. All right, so I know that, and I know to find area, I'm gonna multiply length times width. All right, so I've got perimeter and I've got area. And that's why it was important for me to draw out my shape, my polygon, so I know what formulas to use. All right, then find the perimeter and the area of the polygon. And I'm gonna do that by finding the distance between the points, what you've been doing. Okay, so solve and check. So we drew the polygon. It says the secret chamber is rectangular, so find the length and the width of the rectangle. All right, so to find the length, all right, to go from one point to the next, I would need to write down those coordinates that they gave me, and I would find the distance. Then I would find for the width, I would find the coordinates that lined up, have the same value, and I would subtract them and find the distance. Then I could take those numbers that I found the distance for and I could plug them into my formulas, and I could find perimeter and area. All right? All right, let's try it with our next example. All right, there's a digital map of your hometown is shown in a coordinate plane in which the coordinates are measured in miles. So I know my unit is going to be miles. All right, the map shows your house is at -2, -7. Your school is at 5, -7. And your friend's house is at -2, 1. How far is your house from your school? And how far is your house from your friend's house? Okay, the first thing we need to do is we need to plot out our points. Okay, so I have my house, -2, -7. So let's find that on our grid. All right, go over to -2. I come down to -7, and it's right here. It won't let me make a point right now. There we go. -2, -7, and I'm going to label that as my house. Okay. Next, the school. So go back up to 0. It's 5. Go over to 5, -7. I'm going to come all the way down. So the school is right near my house. Okay. And then my friend's house is at -2, 1. So I go back up to my 0. I go over to -2 and up 1. And I'm just going to put friend. Okay? That's where my friend's house is. Now, they want me to find the distance. Okay? And I have to find it for 2 different things. How far is my house from the school? So let's do that one first. So I'm going to bring my coordinates down. -2, -7 is my house. The school is 5, -7. Okay, which 2 coordinates are different? Okay, the X ones are, aren't they? These 2 coordinates are different. I have a positive and a negative. Are they in the same quadrant? No, they aren't, so I'm going to add them. I'm going to add their absolute values. The absolute value of -2 is 2, and the absolute value of 5 is 5. And 2 plus 5 equals 7 miles. Well, I know it's miles because they told me that's my unit. 7 units or 7 miles in this case. Okay, so my house is 7 miles from the school. All right, now they want to know how far is your house from your friend's house. Okay, I'm going to write my 2 coordinates down for those things. Okay, for my house, it's -2, -7. For my friend's house, it is -2, 1. Okay, this time which coordinates are different? The y coordinates are different, so I'm going to use those. Are you in the same quadrant? No, you're not. So I'm going to add the absolute values. What's the absolute value of negative 7? 7. What's the absolute value of 1? 1. And 7 plus 1 is 8. And we already know our unit is miles. So your friend is 8 miles from your house, while the school is 7 miles from your house. All right, not hard if you'll stop and think about it. All right, now, again, I have help class tomorrow or Thursday, and you should have tried this assignment. Try it, see what you can do, and then you can bring your questions to help class. All right, guys, I wish you the best.